Hello, grade 10 and grade 11. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, uAbudiwa Sos uGobela Maths. And without any further ado, let's look at these questions that we have here. Okay, so we have question 8. It says a cylindrical aerosol can has a lid in the shape of a hemisphere that fits exactly on the top of the can. The height of the can is 16 centimeter and the radius of the base of the can is 2.9 centimeters. So as we can see, we are given the height and also the radius of the can, the cylindrical can. So here we have two shapes in this figure 1. So it's a cylinder and as well as a hemisphere. Now 8.1 says calculate the surface area of the can with the lid in place as shown in figure 1. Now you will remember that I said if you have a cylinder that is closed on top, just like this, and then here, this is closed, then the surface area of the cylinder would have to be 2 pi r squared plus 2 pi r h. But then if your cylinder happens to be open here, so let me say this is for a closed cylinder, and then right here, if your cylinder would have to be open, then the surface area, now remember it won't have two circular parts, so the 2 pi r squared here is telling you that we would have to have the area of this circle here at the bottom and the area of this circle on top here. So which is why we have 2 pi r squared, which represent two areas of the circle. But then here, if this is open, if this is an open cylinder, that means we only have this one circular part. And we can't count that one because it is not closed, right? So the surface area in this case would have to be only pi r squared, so which represents only one circle here, and then plus the 2 pi r h. Now at this point, let's decide, is this cylinder here, is this cylinder can open or closed? Now note that this aerosol here, obviously at this point it would have to be open so that we can have the lid here. So the lid, the one thing that closes the aerosol can is this hemisphere lid here, right? So that means at this point, this is hollow. It's open like that. And then the lid is only that hemisphere part. So in calculating the surface area of the cylindrical can, that means which formula would we have to use? It's obviously this one, because we do understand that this is an open cylinder, right? And then the lid is only the hemisphere. Now, this point here, we are given the volume of the sphere and then also the surface area of the sphere. Here we must calculate the surface area, so we'll just look at this formula here. But the problem is this is the surface area of a sphere, but we are given a hemisphere. Now what is a hemisphere? Hemi is half, so that means it is half of a sphere. So if the surface area of a sphere is 4 pi r squared, then what would be the surface area of a hemisphere? Now obviously that means we will have 4 pi r squared divided by 2, which would give us 2 pi r squared. Then this here would be the formula to calculate the surface area of a hemisphere. Now, if we want to calculate the total surface area of this aerosol can, now we do understand we'd have to say total surface area is the surface area of the open cylinder, pi r squared plus 2 pi rh plus the surface area of the hemisphere. Remember, the hemisphere now is the one that acts as the lid. Right, so this would be pi 2 pi r squared. And then now at this point, we just simply substitute. We have pi, our radius is 2.9 square, then 2 pi, radius is 2.9, multiplied by the height of 16. And then here we have 2 pi, and then our radius again 2.9. Remember, the radius of the cylindrical can will be the same radius of the hemisphere because it fits perfectly in here. And then when you punch all that into your calculator, you get 118.03 pi, which means if you further punch it into your calculator SD, this will be 370.80 centimeter square. And that's how you were supposed to do that. So make sure that you note this. It is very important to understand if you are working with an open cylinder or a closed cylinder. Okay, then let's proceed to 8.2. It says if the lid is 80% filled with a liquid, as shown in figure 2. So when we are talking about the volume, we are talking about the capacity, how much liquid it can hold, or how much of the amount of substance that will be filled in there it can hold. As shown in figure 2, calculate the volume of the liquid in the lid. Right, so let's check right now. We have the volume, 8.2. If we are to calculate the volume of hemisphere, we do understand that again here we are given the volume of a sphere. So obviously the volume of a hemisphere would have to be half of this. So it's simply 1/2 multiplied by the volume of the sphere. Then pi r cube. Then now let's calculate. We have 1/2 times 4/3 pi. And then the radius is what? 2.9. And then cube that. Simply punch all of that into your calculator. You will get 16.26 pi. Right. And then they say if the lid is 80% filled with a liquid, as shown in figure 2. So this is figure 2. So it's 80% filled with the liquid. And then calculate the volume of the liquid in the lid. So this represents the 100%, the volume, the maximum capacity of the lid, right? But then we are told that this is only filled up to 80%. So that means we have to calculate 80% of the full capacity of the lid. So how do we do that? Simply 80/100 multiplied by the 16.26 pi, right? And then when you punch all that into your calculator, you get 40.86 centimeter cube, right? Remember, it's the volume. Then that's how you were supposed to calculate that. So first you needed to calculate the total volume, the total capacity of the hemisphere here, the lid hemisphere, and then from there on you calculate the 80% of that. Okay, then let's proceed to the next question. Okay, so now we have question 8. It says consider a community reservoir tank in the shape and form below, made from a cylinder with a height of 19 meter and a hemisphere half of sphere. So now they're mentioning what is a hemisphere. It is half of a sphere with a radius of 12 meters. Then we are given the formulas. So this is obviously the formula of a sphere. And then what we have here is the volume of the cylinder. This is the total surface area of the cylinder, and this is the total surface area of a sphere, as we have seen with the previous question. Okay, so now calculate the volume of the tank. We do understand that this community reservoir tank is made out of two shapes. It is one, the cylinder, and two, the hemisphere. So that means if we wanted to calculate the total volume of the tank, we would have to consider calculating the volume for both the shapes here. So we have 8.1. Let's start by the volume of the cylinder. So we'll say to calculate volume of cylinder, this is simply V is equals to pi r squared h. And then what is our pi? Pi is just pi, the radius is 12, and then square that, the height is 19. So you just simply punch all that into your calculator, and then you will get 2,736 pi. Now note this instruction here. They said leave the answer in pi. So we are not supposed to press SD after here. We are just supposed to leave it like that. Then again, we calculate the volume of the hemisphere. So volume of the hemisphere, then the volume of the hemisphere, we are given the volume of the sphere there. So the hemisphere would have to be half that. So half multiplied by 4 over 3 pi r cube. And then this is 1 over 2 times 4 over 3 pi. The radius is still the same because as we can see, the hemisphere fits perfectly into this cylindrical tank. Right, so this is 12 and then cube that. So it will give us what? We will find 1152 pi. Right, and then obviously for the total volume now, for the total volume, we understand that, let's say this is V1 and this is V2. We'd have to add V1 plus V2, volume number 1 and volume number 2. So that's 2,736 pi, and then plus 1,152 pi. And then when you add those ones together, then they will give you, remember, you are just adding the coefficients there. So it's 3,888 and 88 pi, and then obviously meter cube. So let's not forget the SI unit. So I was supposed to say meter cube all along here, and then that's it. So that's our total volume. So first calculate the volume of the cylinder, calculate the volume of the hemisphere, and then calculate the total volume. So that's how you could have got that 6 marks over there. Okay, now let's proceed to 8.2. It's saying calculate the exterior. Now this is a keyword here. Calculate the total exterior surface area of the tank. Now when they say exterior, that means you must consider everything. So it's more like when you are calculating the surface area of the cylinder here, you assume that the cylinder is closed, right? Because you are trying to calculate the total surface area of all the shapes that you have. So the total surface area of the cylinder and also the total surface area of the hemisphere. So here we are not going to consider that this is an open cylinder, but rather we will assume that it is a closed cylinder, right? Now, if it is a closed cylinder, that means that the formula that we should use for the cylinder is exactly like this. So you don't have to take out the 2 there. Okay, so 8.2, once again, remember we must calculate the total exterior surface area of the tank. The tank is still made out of 2 shapes, the cylinder and the hemisphere. So we can start by saying surface area of cylinder, and then we'll just consider this to be area number 1. And then this is 2 pi r square plus 2 pi RH. So this topic is very simple as long as you know the formulas, but then you know that sometimes you are not given the formulas. So the tricky part becomes the fact that you have to memorize the formulas or know the formulas in order to answer some of the questions. Then this is 19 here. And then you simply just punch all this into the calculator. Remember here, they did not say leave your answer in pi. So that means we can simply punch it and then SD it also again. So it will give us 2,000. Here they said round off your nearest to the nearest square meter. So here we have 2,337.34 meter square. So at this point, I'm not going to round off because I've not got to the final answer. So I still need to calculate area number 2, which is surface area of hemisphere. And then I will take that to be area number 2. This is equals to, if the total surface area of a sphere is this, then what is the total surface area of a hemisphere? It's divided by 2. So we're going to have 2 pi r square. This is 2 pi. And then the radius is still 12. And then if you punch that into your calculator, another way in which you can write that, obviously your A2, you can say it's 1 over 2 and then 4 pi r square, which is still the same as just writing 2 pi r square, right? So your choice. Then if you punch that into your calculator, you get 4 52.39 meter square. And then for the total surface area, the total exterior surface area, then we have to add the areas of the two. So it's 2,337.34 plus 452.39, right? And then this is giving us 685.73 meter square. But then remember, the instruction is round off to the nearest square meter, right? Now the nearest square meter here would have to be 686. So you would have to say it is approximately, so this is the sign for approximately, 686 meter square. So the total surface area is 686 meters square. Hallelujah. Okay, let's now proceed to the next question. Okay, so we have question 10. It says the shard is comprised of an array of glass shards that mesh to form an elongated pyramid. This unusual building is situated near the Thames or the Thames, however they call it, in London, and is one of the tallest buildings in the UK. The base is a square of 50 meter by 50 meter. So this elongated pyramid is on top of a square base, which has the length 50 by 50, and the perpendicular height is 306 meters. Using the formula for the surface area of a pyramid below, answer the questions which follow. We have 10.1. It says determine the surface area of the glass sides of the shard building. If they're saying we must determine the surface area of only the glass sides here, that means we are only looking on the part of the pyramid, right? So we are not really interested on the base in which the pyramid is placed. So that means the part of the equation that we are supposed to use is only this one here, because we are only looking at the what? At the surface area of the glass sides, not the whole building there. Okay, so now note that we will have 1 over 2 times the perimeter of the base, which the perimeter of the base would have to be that square base, and then multiply by the slant height. But then we don't have the slant height. And what is the slant height? I did mention that the slant height is the hypotenuse of the right angle triangle that will form there. So suppose that the shape that we have is like this. Remember, this is on top of a square base. So let's say this is a square base right here. And then this is our pyramid forming like this. So our pyramid is elongated like that. Okay. So this here is our pyramid. And then all the way there. But then remember, we must draw our perpendicular height here. And then our perpendicular height will be right here. And then it goes all the way like this. It forms a base. And then our slant height is the one that comes from here and then joins to this part. Now we are told that the square here has length 50 by 50. So that's 50 meter, 50 meter, 50 meter, 50 meter like that. So this is a square. But then we always know that from forming that perpendicular height here, the base of the right angle triangle is always half the length. It is half the length of the square base here. So if this we have 50 meters, then this is supposed to be 25 meters. And then here about the height, we were already told that the height is what? Is 306. The perpendicular height that we had drawn here is 306 meters. You get that? So this is the height. This is for the height, h. Now, the slant height is the hypotenuse. This is the slant height. This is what we are looking for. To calculate the slant height, we always use Pythagoras theorem. So it will say s squared is equals to 25 square plus 306 square. Then you simply just grab your calculator. It's going to be 25 square plus 306 square, which you can just simply punch it inside the brackets or inside the square root already. And then that is supposed to give you what? 307. So our slant height is 307.019, which is 02. Let's say 02 meters. Now that you have the slant height, that means you can now calculate the surface area of the glass sides. So you will say surface area. Remember, we are not calculating the total surface area of the pyramid. We are only focused on the glass sides of the shard building. So that means our formula will have to start here. 1 over 2 times the perimeter of base multiplied by the slant height. Right. Now the perimeter of the base, we know it to be what? The perimeter of the base will just be represented by 4 multiplied by the length. Why that? Because this is a square. And if we want to find the perimeter, that means we'd say 50 plus 50 plus 50 plus 50, which in simple terms, we can just say it's 4 multiplied by the 50, or 4 multiplied by the length of the square. This is 1 over 2 multiplied by 4 times 50, and then multiplied by the slant height, which is 307.02. Now you simply just grab your calculator. 1 over 2 multiplied by 4 times 50 multiplied by 307.02, and then you get a value of 30,702 meter square. Right. So that's it. That's it. And then 10.2, they say now determine the angle of inclination of the sloping glass sides with the horizontal base. Okay, so they want the angle of inclination. The angle of inclination is this angle right here. This is what they are looking for. Now, if we want to calculate the angle of inclination, we know we have to use the trig ratio tan. So this is tan theta is equals to opposite over adjacent. According to SOHCAHTOA, we know that tan is opposite over adjacent. Now from this reference angle here, what's your opposite side? It's the 306, the perpendicular height. And the adjacent side is the 25 right there. And then all you have to do now is leave the theta here and say tan arc, or arctan, 306 over 25. Grab your calculator and punch all of this into your calculator. Let's check. We have a arctan 306 divided by 25. This is going to give us 85.33%. 33 degrees, not percent, degrees. Okay, nice. So that's it. That's it for your 10.1 and 10.2. And now let's proceed to the next question. Okay, so now we have question 4. It says a pyramid with a square base with a side length of 16 centimeters sketched below. P lies on the square base directly below A. At this point from the questions that we have already answered, you can now identify the trend that it is very important to note how to calculate the pyramid with a square base, because they like to show it more. The volume of the pyramid is 640 centimeter cube, and then we are given the formula for volume of pyramid. It's 1 over 3 times the area of the base, obviously, as we know, and then multiply by the perpendicular height. And then 4.1 show that the perpendicular height, which is your h, of the pyramid AP is 7.5 centimeters. So your AP represents h. Okay, so easy peasy, it's even 2 marks. All you have to do is you are already given the volume, so you'll say volume is 1 over 3 times area of base, and then multiply by the perpendicular height. The volume is 640, and then you have 1 over 3. Now this is a square base, meaning this is 16 by 16. So 16 times 16 and then multiply by h. So that means doing our maths here, we'll say what is 1/3. So 1/3 multiplied by 16 times 16. This is going to give us 640 here. And then here we have I'm getting 256 over 3 and then h. Now, obviously, if we want to find our h, we can just multiply by the reciprocal both sides. So what you do, that side, you also have to do this side. And then you can, these ones will cancel. You'll be left with the h. And then if we say that number there, multiplied by 640, this is going to give us 7,5. So 7,5. Therefore, our h is 7.5 meters. Right. Now, others can just simply say 640 divided by 256 divided by 256 over 3. Still the same thing. Then if you came here and say, okay, this is 640 divided by, or you say over 256 over 3, right? So 640 divided by 256 over 3, you would still get your h as your 7.5 meters. And then in 4.2, they say hence determine the total surface area of the pyramid. Once a question says hence in maths, it simply means from whatever that you have proven above, then use that to still continue solving this one. Now, we are not given the formula for the total surface area of the pyramid. So which means they wanted you to know that. So 4.2, total surface area of a pyramid, we know it to be the area of base plus 1/2 times perimeter of base multiplied by slant height. So always we know whenever it comes to the total surface area, the one thing that we must first find is the slant height. So we have the 7.5 here, but then what is the length of PT? We know that the base of the right angle triangle here would have to be half the base of the square there. Right, so if it's 16, that means here we must have 8 centimeter. Now we have 7.5 and 8 centimeter. We can now calculate the slant height using Pythagoras theorem. So this will be s squared is equals to 7.5 square plus 8 square. And then as you know, you can just put that inside the square root. And then it's going to give us 10.9658. Let's just at least round off to 4 decimal places. And then centimeters. Now to calculate the total surface area of the base is a square. So that would be length multiplied by length plus half perimeter of the base. So obviously it's 16, 16, 16, 16. So that would give us 4 multiplied by the length. And then times the slant height. So we have 16 by 16 plus half 4 times 16 and then multiply by the slant height of 10.9658. Then at this point, you simply just grab your calculator, punch all of this into your calculator, you'll get 606.91 centimeter square. Right, round it off to 2 decimal places. And that's all you do. That's all you do. Okay, so done with 4.1 and also 4.2. Let's proceed to the next question. Okay, so we have another question here. It says a spherical glass ball is tightly packed in a box. The box is in the shape of a cube, as shown in the picture on the left. The radius of the ball is 6 centimeter. The diagram on the right shows the cross-section of the glass ball placed in the box. what volume of the box remains after the glass ball is placed in it, right? So we want to find the volume that remains. Now, this is very simple. We have two figures here, or two shapes. One is a cube, right? And then the other one is a spherical glass, or a sphere, right? Now, what we can do is let's calculate the volume of the cube, and then let's also calculate the volume of the sphere. Take the volume of the cube, subtract the volume of the sphere, and then what you have remaining here is obviously the volume that remains after the glass ball has been placed in it. So simple stuff. Right. Okay, so we'll start by saying volume of cube. And then as long as you know the formulas, the volume of the cube, or the volume of the board, is just simply, we know it to be what? So V is length cube, right? And then the length of the cubes, we are being told that it's what? It's, let's read here. They say the radius of the ball is 6 centimeters. So we are only given the radius of the ball. But looking at the diameter of the ball, we can see that the diameter of the ball is exactly equal as the length of the cube, right? So if this is 6 centimeter and here, this would be 6 centimeter. That means the length of the cube would have to be 12 centimeter. Also here, this is the radius, it would be 6 centimeter, and also here 6 centimeter, meaning also here this is what? 12 centimeter. But we know the volume of the cube to be length cube, so that means that's 12 cube, right? And then when you punch 12 cube in your calculator, you get 1,728 centimeter cube. This is the volume of the cube. Now, let's calculate the volume of the sphere. So the volume of sphere, again here we must know the formula. We were not provided with the formulas. And then if a formula is not provided, guys, it is just up to you. So that's why I'm saying it is very important that you study your formulas. Don't just say the formulas will be given to us, because as you can see with these questions, sometimes the formulas are given, sometimes they are not given. So to be on the safe side, know your formulas. Then this is 4 over 3 pi r cube. So this is a sphere, right? Not a hemisphere. Then 4 over 3 pi, and then our radius 6. So 6 cube. When you punch that into your calculator, you get 288 pi. So I'll just leave it in terms of pi, and then centimeter cube. I don't want to round off as yet. Then if we want to calculate the volume remaining, so volume remaining, we do understand that it will be the volume of the cube, which is 1,728, minus the volume of the sphere, which is 288 pi. Now at this point, I can subtract that and press SD, and then it will have to give me 823.22 centimeter cube. So this would have to be the volume remaining. So the volume of the unshaded part here. Okay, and that's it for this question. Let's proceed to the next one. So at this point, you can see that we are simply doing one and the same thing. Okay, question 6 says the solid below was made by drilling a right circular cone out of a right rectangular prism. That is to say the cone is removed from the prism. P, Q, R, and S are vertices of the prism such that PQ is 20 centimeter, QR 15 centimeter, RS is 12 centimeter, and the radius of the cone R is 4.5 centimeter, and the height of the cone H is 6 centimeter. Then the slant height of the cone is given as L, right? Now they say calculate the total surface area of the solid. Now, I want you to think of something when we are talking about the total surface area. Think of it as if you are trying to paint this figure here, or the solid. If you were to paint the solid, that means you'd paint all the sides here. Then all the sides here will be filled with paint, all the exterior sides, right? So the total exterior will be filled with paint. So you'd paint here. Now, coming to this point whereby the cone has been drilled out. If you had to paint the whole surface, that means you'd paint inside here. You'd even paint this part here. But then the only part that you would not paint is the circular part here, because it's no longer there. Remember, now we have a circular hole there, right? Including this cone-shaped hole, but then obviously this one would also be covered in paint because you are trying to make this one color here. So this would be covered in paint. Now I'm painting this picture to you so that you understand the calculations that I am going to do here. So, okay, now in green, let's say this is the part that will not have any paint because this will be just, this part won't be here. It will be hollow here, right? Okay, let's now start our calculation. To calculate the total surface area, we've only been shown the equation of the total surface area of a cone, right? Now, this here is a right rectangular prism, of which they expect you to know the formula to calculate that by now. So we know the formula to calculate the volume of the prism, volume of rectangular prism. Then it is simply V, not the volume, it is the surface area. Sorry about that. So to calculate the surface area of the rectangular prism, that surface area is equals to 2 length times breadth plus length times height plus breadth times height. So they expect you to know this formula. Now at this point, what can you do? Simply, what is your length? So this will be length, breadth, and then height. So length times breadth, that's 20 multiplied by 15. Length times height, that's 20 multiplied by 12. And then breadth times height, that's 15 multiplied by 12, right? Now, if you punch all this into your calculator, you will obviously get for this one here, all of this into your calculator, you'd get 1,440 centimeter square, right? So you can confirm with your calculator. Then now we have the surface area of the rectangular prism. But the total surface area of the cone is this. Let's break it down to the circle and also this part here, right? So this part here. So this one, we'll call it the lateral part. So let's break it down to that. Now, if we are to calculate the surface area of the circular base, surface area of the circular base is simply just pi r square, which will give us pi, and then our radius is 4.5. So this is 4.5 square. If you punch that into your calculator, that's 63.62 centimeters square rounded off to 2 decimal places. Now, let's calculate the lateral surface area of the cone. So which means this part here. This will give us pi, r, and then l. Remember the l, we've been told that it is the what? The slant height. Now obviously we don't have the slant height, so that means this is the part whereby we need to come here and then use our Pythagoras. We have our height as 6, we have our radius as 4.5. To calculate the slant height, it will simply be L squared is equals to 6 squared plus 4.5 square. Then you can simply just put all of this into the square root. Then your slant height, L, would have to be equal to what? So 7.5 centimeters. Then you take that 7.5 centimeter, you will put it here. So you have pi, the radius is 4.5, and then now the slant height is 7.5. Right. Now when you calculate that, it's giving you 106.03 centimeter square. Now this is the part. Now we've calculated the area for everything. The total area of the surface cone, which is made out of the surface of the circular base and the lateral surface area of the cone. So when you add those ones together, they form the total surface area of the cone. We have calculated the total surface area of the rectangular prism. But then let's go back to this. I said, think of the total surface area as the part, the exterior part that you will have to paint, right? So we do agree that you would have to paint all of this rectangular prism, but then the only part that will be without paint is this hollow shape here. Remember, the paint will still go in here, right? So that this is the same color as all of that. So the paint will still go in here. The only part that will not be painted, let's all agree it will be the circular part here. So that means in calculating our total surface area, we must subtract the circular part of the cone because that part will no longer be there. So it can't be painted. Then for TSA, total surface area, we would have to say now we have the total surface area of the rectangular prism, which is 1440. And then also this part, the lateral surface area will be painted. So we're going to add 106.03. But then we're going to subtract, right? We will subtract the surface area of the circular base because we are saying this part will no longer be there. So this is 63.62. Then now, to find your total surface area, you have to punch all of this into your calculator, and then it will have to give you 1,482.41 centimeter square, right? So that's all you needed to understand there. To understand that you did not have to subtract the whole of the total surface area there of the cone, but only the circular part, right? So I hope it makes sense. Let's now proceed to the next question. Okay, so now we have this question here. It says, in the diagram below, a pyramid is mounted on top of a rectangular prism with a square base. The height h of the pyramid is 0.6 meters. So this is the pyramid on top here. And then each side of the prism is 5.2 meter long, and the height h of the prism is 2.5 meter, right? So it's telling us that this is a square base, right? If all the sides are equal, and we've also been told here of a rectangular prism with a square base, so it has a square base. Then 1.1 says calculate the total volume of the figure. Again, at this point, we understand that we have two shapes. It is the rectangular prism and also the pyramid. So in calculating the total volume, we must calculate the volume of the rectangular prism and also the volume of the pyramid. And then right here, we are given the formulas. So for 1.1, we will indicate a volume of pyramid. Volume of pyramid will be equal to what? So let me write with a blue pen. So the volume of the pyramid is V is equals to 1/3. The area of the base, this is a square base. So area of the base will be length multiplied by length, and then times the perpendicular height, so which is h. And then now we have 1/3. And then this is the length is 5.2. 5.2 multiplied by 5.2, and then multiplied by the height of 0.6. Then when you punch all that into your calculator, you will get 5.408 meter cube. So you can just SD that fraction there. It will give you in decimals. And then, okay, we are not done. We must also indicate the volume of the prism. Volume of the rectangular prism. So we'll say the volume of the rectangular prism is volume is length multiplied by base multiplied by height. So length is 5.2. Base again will be 5.2 because remember it is a square base. and then your height is your 2.5. So this will give us 5.2 multiplied by 5.2 multiplied by 2.5, and then your answer there will be equal to 67.6 meter cube, right? Again, if you SD that fraction there, you get this. And then for the total volume, so total volume will now be the volume of the pyramid plus the volume of the rectangular prism. So that's 5.408 plus 67.6, which will give us 73.008 meter cube, which you can write in two decimal places as per instruction of the exam as 73.01 meter cube. Right. That's how you were supposed to show that, only for 3 marks. Okay, then 1.2 says calculate the slant height of the pyramid. So already we've been doing that a couple of times now. We know what to do. So if we are to calculate the slant height, then we must extract the triangle out there to say that we do understand that our perpendicular height will be 0.6, and then we'll have the base of the rectangle there, and then the slant height is this. But then we know the base of the rectangle must always be half the length of the square base. So if the square base is 5.2, then that means in order to find this one, this would have to be 2.6. Let's see. 5.2 divided by 2. Yes, that's 2.6, right? So always note that. Every time you are looking for the base here of the rectangle, then you must always know that it is half the length of the square base here. Then we have 0.6 as our height, 2.6 as our base. For the slant height, we'll say s squared is equals to 2.6 square plus 0.6 square. Then obviously put this inside the square root. Then your slant height is equals to what? 2.67 meters. Right, so 2 marks, that's all you needed to do. And then now 1.3 says determine the total surface area of the figure, the total surface area of the figure. Now, we are not given the formulas for the surface area, but then we do know that the surface area of a total surface area, let's start by the pyramid, will be represented as what? The area of base, and then plus 1/2 times the perimeter of the base multiplied by the slant height. So let's start by calculating surface area of pyramid. Surface area of pyramid. Okay, area of the base, remember this is on top of a square base, so that would have to be the length multiplied by the length, then plus half the perimeter of the base, that would be 4 times the length, because remember, 5.2 here, 5.2, 5.2, 5.2, so that would represent the perimeter of the base. Then multiply by the slant height. Let's now substitute. Our length is 5.2, then times 5.2, plus half, we have 4 times 5.2, and then multiply that by the slant height that we did calculate is 2.67 from the previous question. Then now, when we punch all that into our calculator, we get 54.81 meter square. And then for the total surface area of the prism, rectangular prism, we do know that it is there will be 2 length times breadth plus length times height plus breadth times height. So we have 2. This is our length, this is our breadth, this is our height. So length times breadth, remember here it's still 5.2. So this is a 5.2 times 5.2, then plus length times height, it's 5.2 times 2.5. And then lastly, we have base times height, which is 5.2 again times 2.5. Then when you punch all that into your calculator, you are supposed to get 106.08 meter square. And then for the total surface area of the figure, then what must we do? It's the total surface area of the pyramid and the total surface area of the prism. So it's that 54.81 plus the 106.08. And then when you punch all that into your calculator, you will get 160.89 meter square. Okay, so that's it. That's how you were supposed to calculate that one. So all for a total of, is it 4 marks, right? So yes, there was 4 marks in total. We have 9 marks. Then that's how you were supposed to tackle that question. Let's still proceed to yet another question. Final question. Okay, so we have question 5, which this one here is strictly for the grade 11s. So if you are a grade 10 watching this, you can be making your way out because this might confuse you. Then in the diagram below, F is equals to 35 degrees, E is 90 degrees, GDF is 14 degrees, and FG is 7 meters. Then 5.1.1 says write down the size of EGD. Right. Now, where is EGD? EGD is this angle here. And then this is only 1 mark, so that means it's something that we should see just quick. But then knowing your triangles and also the theorems involved with triangles, you know that if you have an angle there, that is an exterior angle of a triangle. And we do know the theorem that says an exterior angle of a triangle must be equal to the 2 opposite interior angles. So that means EGD is just simply a sum of this angle and that angle. So if you say 14 plus 35 degrees, then you are supposed to get what? 49 degrees. So hence they say write down. So you are supposed to just know it from a theorem. Then now let's indicate we now have 49 degrees here. Now they say calculate the length of DE. DE is this one here. So we can see that we have a right angle triangle EDF, but also another right angle triangle is DEG, right? So at this point, what can we do? We can use our sine rule here. So we have DG over, so the sine rule obviously is used on non-right angle triangles. So I'm trying to use the sine rule on this red triangle that you see that I've marked out here. So I will say DG over what? Over sine F, right? Remember, it must be the side versus the angle that it is facing, right? So DG, this is DG, and then its opposite angle F. So DG over sine F is equals to what? GF. So where's GF? There is it. So it's GF over sine D. So I'm using the sine rule here. So I'm using the sine rule. So sine rule, remember, it says if this is A, B, C, then the way I write it, this should be side A, this should be side B, and then this should be side C. So angle A is opposite angle side A. Angle B is opposite side B. Angle C is opposite side C. Hence you have sine A over the side it is opposite to. Sine B over the side it is opposite to. Sine C over the side it is opposite to. So even here, we can see that I only just wrote it in inverse form. So started with the side over the angle it is opposite to. Now, okay, the DG here, I do not have the size for DG. That's what I'm looking for. But then I do have the angle F. So that's sine 35 degrees is equals to GF. I do have the length for GF. It's 7. And then sine D, we are given that angle there as 14, right? So 14 degrees. So let me erase here so that you can see. Right, then to calculate my DG, I know that it is simply just 7 multiplied by the sine 35 degrees and then over sine 14 degrees. So cross multiply here, eventually the sine 14 will have to divide. And then DG would now have to be equal to what? 16.60 meters. So let me fill it in here. Now I have 16.60 meters. But then remember, I'm looking for what? I'm looking for the size of DE. At this point here, if I were to consider this angle here, this is a right angle triangle, right? So let me mark out this. So now we are looking at this right angle triangle here, DEG. This right angle triangle here. Okay, so if we are to consider this right angle triangle there, then this is what we must see. It's the fact that we can now use our SOHCAHTOA here. SOHCAHTOA, remember this can only be used in right angle triangles. Now if we are to consider this angle and I'm looking for DE, the DE here is the opposite side, and then the 16.60 meters for DG that I just found is the what? Hypotenuse side. Now, which trig ratio must work here? I have the opposite. I'm looking for the opposite, but I have the hypotenuse. So looking at this, we can see it's sine. So again, I can say sine 49 degrees is equals to the opposite, which is DE, over the hypotenuse, which is now the DG there. Now this will be DE is equals to DG multiplied by sine 45, which is the DG is 16.60 and then sine 49 degrees. Then when you punch that into your calculator, it should give you 12.53 meters. Okay, so that's how you were supposed to go about that one. So first, use the sine rule in order to find this common side here, right? Every time you're trying to solve this kind of questions, always tackle them from the common side. The reason why I had to calculate DG, it's because DG is a common side between these two triangles that I have identified. So it is much easier to solve using that. So now that I've identified that DG is a common side, let me use the sine rule to find DG. And then after I found DG, I can now use SOHCAHTOA, which is I'm going to use the trig ratio sign in order to then find the length of DE. So that's how you were supposed to get that 5 marks. Okay, so now 5.2.1 says, show that the area of the octagon is 2 root 2 r square centimeter cube. Right, okay. So now, this point we can see that if we are to look at this octagon, we can produce a lot of triangles here. So if we can just connect this to the corners, I want to determine how many triangles can we make out of that. So how many triangles? This is 1, 2, 3, 4, 5, 6, 7, 8. So octagon also produces 8 triangles, right? So all these triangles here, we know them to be so the property of of this is that all these triangles here, remember, these are angles around a point, right? So all these angles here must give us 360 degrees. So if I wanted to find the angle in here, the angles in here, then I would simply say 360 divided by what? By 8. And then if I say 360 divided by 8, I find that it is 45 degrees. So that means the angle here, remember these are like pizza slices, so they're all equal. So 45 degrees, 45 degrees, 45 degrees all the way here. Right. Okay, now that we have that, let's now understand this. They say show that the area of the octagon is 2 root 2 and then r square. So now we have found that that is 45 degrees, and all these lengths here, they represent the radius. All these lengths here are representing the radius. So this is r, r. Now, what formula comes to mind here? Remember, if we are looking for the area, and this is not right angle triangles, these are non-right angle triangles. We know that in order to find the area, remember if it was a right angle triangle, to find the area, you'd simply say half base times height. But then if these are non-right angled triangles, meaning they are not right angles, then the way to calculate the area, we know the area rule says you can say it's half AB sine C, right? Whereby, how do you apply that one? You say if you have triangle ABC, this is side A, this is side B, this is side C. If you do have the angle A here, then it simply means take this side, take that side, and also this angle here. Right. So it's a side, and then angle in between, which we can see it here. The side, and an angle in between. For all of them, side, angle in between. But then the sides are all equal in length. They are all radi. So that means my area here would have to be what? So the area of this figure would have to be 8 multiplied by half AB sine C, the area rule. Why 8? Because I will have 8 similar triangles. So if I want to calculate the total surface area of the octagon, I must calculate this, the area of each and every triangle there. So this is 8 multiplied by half. The A is R, and then the other length is also R, and then we have sine what? The angle is 45 degrees for all these triangles. Then I have 8 multiplied by, so if you just punch that into your calculator, that's half multiplied by sine 45, it's going to give us root 2 over 4. Root 2 over 4. And then r square. Now, obviously, if you say 8 multiplied by root 2 over 4, the 8 and the 4 will divide out. So how many 4s go into 8? It's 2. So 2 root 2, and then r square. And then that's it. That's the area. That's the area of the octagon. Then we have proven that it is equal to that. So centimeter square. Now, 5.2.2 is saying if r is equal to 5 centimeter, calculate the perimeter of the octagon. Calculate the perimeter of the octagon. Now, obviously, the perimeter of the octagon, we'd have to only calculate that after we have found the sides here. Remember, the perimeter speaks to the outer side. So this is what determines the perimeter here. So the perimeter can be determined by this. So this can determine the perimeter. All the sides that I'm marking out here, if you add all the sides, they will give you the perimeter of the octagon. Remember, perimeter is just the outer part of a figure. So the outer part of a figure. But now, note that we do not have the length of these sides, of which we do know they will all be equal. So how do we come to the point whereby we know that we are now given the radius? So let's extract out one triangle there. So remember, this is R, and then 45 degrees. The side that we are looking for is this one. Let's name it K. So now, since we are given the radius, That means we have 5 here, 5, and then 45 degrees, and this is what we are looking for. Now, again, in this situation, if we have a side, and an angle in between, and we are looking for a side that is opposite the angle in between, what rule must we now apply? We can all agree it is the cosine rule. So with the cosine rule, this is how we do it. So we'll say the cosine rule, we know it says a squared is equals to b squared plus c squared minus 2bc cos a, which this part we can edit it to be what? So remember, said the side that we are trying to find, let's say it's AB. So it's AB square. This will be equals to what? The radius square plus another radius square minus 2 radius times radius, and then cos what? Cos the angle there, which is 45. So let's just leave it as cos angle A. Now let's start to substitute our radius. They said it's 5. And then if in here 5, then this is 2, 5, and then 5. And then cos what? 45 degrees. And then when you punch all that into your calculator, you get 14.64. But do not be carried away. This is still AB squared. You need to get your line for AB. So you square both sides. Then AB gives you what? 3.83 centimeters. But remember, if this is 3.83 centimeters, this is also 3.83 centimeters, and everything in here, all the sides here will be equal. And how many sides do we have on an octagon? 8 sides. So that means for the perimeter of the octagon, we are going to say 8 multiplied by 3.83. And then this is supposed to give us 30.61 centimeter. Remember, with perimeter, it's just centimeter. And then with area, it would be square centimeters. And then with volume, it will be cubic centimeters. So it is very crucial to know for the perimeter, if the sizes are given in centimeters, it's just centimeters. And then for the area, it would be centimeter square. And then for the volume, it would be centimeter cube. So you always need to indicate the SI unit when solving these questions. And then we have came to the end of our marathon. So I hope you enjoy these questions, and then they help you understand more of how to solve these measurement questions. But then with all that being said, please press the thumbs up button if you have enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit the subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.